Hello again. Yesterday I explained to you that the air handling units using fans, and fans are driven by motors and controlled by different type of controls that you can choose, and some of these controls could be variable speed drivers, soft starters, or contactors. You can use direct online start, or you can use start delta. So here's your contactor. I explained to you also how the contactor work. You have a circuit breaker and then a push button. Anytime you'll push that button in the contactor where the solenoid it is, you'll create an electromagnetical field that will move a shaft downwards, and on that shaft you have the switches connected that will close a circuit, which can be single phase, three phase. You can have a control circuit, etc. Yesterday we covered the DOL inline start, but we talked about circuits which didn't have overload protection. Like you see, this one has got an overload protection. It's got a motor circuit breaker, an isolating switch, and then you have the main circuit breaker. Also, I explained to you that the main circuit breaker is to protect the wire and not the motor. Now let's talk about motor control with contactors and overload protection. Unlike this one, which doesn't have an overload, I like to choose a system which have an overload because I want to protect my motor. You can buy from the market different type of contactor with overloads. They come in pair. Don't try to mismatch them. You'll have some little problem here and there. I explained to you what type of faults you can get on a contactor, and finally let's talk about this overload. But first let's see how a circuit will look like. You have your motor, you choose a contactor, and you don't want to wire the contactor directly into the motor. That's why you will fit an overload into this contactor, and then you will wire the circuit. Until here everything it is okay. Now we have the overload, and how the overload works. You have the motor running amp set, that little place where you can use a screwdriver to set the amps. You have the stop and reset switch, and then you wire to normal close and normal open. The signal cables, they're very important, and I will explain to you how these signals are working. You see the normal close circuit is closed when the system it's okay, and the normal open circuit it's obviously open. When the system is healthy, the normal closed circuit will send the signal to the running circuit. When the system is on alarm because the motor has been overloaded, the overload will send a warning signal, probably to a beacon, to a light, or to PLC if you want. And anytime you will choose an overload, you will see the motor running amp set. You really have to read the batch onto the motor to see the motor's maximum running amps. You don't want to burn the motor, and you want to choose the appropriate overload. So on the batch you will see, amongst other things, the volts, the hertz, the amps, the kilowatts. So you have to look to the amps and to choose the right overload. Now let's get further, see how this is working. Let's talk about a basic circuit controlled by an on-off switch. This circuit will have an overload protection device, but it is imperfect. It's far from being a good circuit. As you remember, we talk about this type of arrangement. We have a circuit breaker that controls the electrical wires. We have an isolating switch. We use it for when we repair the unit or emergencies. We have a contactor with an overload to protect the motor. Obviously we have the motor, and we also have a form of control like a programmable logic control, but we choose to talk about a basic switch on and off. And this is our arrangement. Let's turn on the circuit breaker. We have now a power supply to the contactor. We press the switch, you turn on the contactor, the motor is running, and as you look now onto the overload, you'll see the normal closed circuit is closed. The mechanical or electrical fault on the motor will hit the overload. So the motor is running well, but now the motor got a fault and the overload device start to hit. If you remember, I told you the overload, it's connected to the running signal, and as long as the normal close switch will return the signal, the system will run. So the overload start to hit more and more, and it will come to the point where this running signal will be interrupted because the overload trip, and then the overload will have a normal open signal closing the circuit, and it will disconnect the normal close circuit and will send an alarm signal. That will turn off the motor for safety. You can press the reset switch as many technician does, but in a while this will happen again, so you're supposed to check the motors, the wiring. If you'll have a severe short circuit, then the overload might not have time to heat up, and under such condition the circuit breaker will trip before the overload to turn off the circuit. So see, now the circuit breaker in the left hand side on the top is tripped. He disconnect the power supply to the contactor, but if you look to the overload, to the normal close switch, is still active, and the running LED, the running light, is still on because the control circuit is not affected. This is not a very good design, but I found this type of design, so I just wanted to show it to you. Now you understand the basic of a simple circuit that uses switches and contactors with or without overloads. Now you know the value of an overload integrated into a system. On the next video I'll talk about latch system, on and off, momentary push buttons. I will show you incorrect circuits, better circuits. We'll talk a little bit about start delta, and then we'll jump on programmable logic controls, how you can integrate contactors on these PLCs. We'll talk about signaling. Then we'll talk about variable speed drivers. What are they doing? What are we using them? And following to jump on more complex circuits, air handling units with motors driven by variable speed drivers, programmable logic control, which switch the variable speed drivers instruction to run standby motors. If some of the motors will get faulty, the other ones should take over. And finally we'll talk about full integration on a SCADA and the importance of monitoring a system. Thank you.